Okay, so we're going to continue on negative exponent and scientific notation, which is section 4.2. Yeah, all right. Okay, so let's open Math 115, 4.2. All right, so this is where we left yesterday. Yeah. So if I have 2.55 times 10 to the 7th, then it goes to the right, 7 decimals. And then if it is negative, then it goes to the left. Okay, so this is from scientific notation to decimal. Yeah. So this is, you have this in scientific notation to decimal. Now, we will do the other one, which is from decimal to scientific notation. So, next one. Yeah. So, for example, convert to scientific notation. All right, so convert to scientific notation. So we have decimal. Let's just say number 1. 287,000,000,000. Okay, I don't know how many sevens, how many zeros there. So that's a big number. All right. And then I have 65,000, and then I have a very small number, 0.000042, and I have 0.0007. All right. Good. So how many zeros is this? So 3, 3, okay, and this is 3, and this is 3, and 3, okay, 3. All right. So how am I going to do it? So scientific notation is n times 10 to the n. So this n, is there any restrictions on this n? Any restrictions on this n? What values can I use, like 33 times 10 squared? Can I write it like this? No, n has to be between what? 1 and 9. Yes, so n has to be between 1 and 10 actually, but not including the 10. So now I'm going to put my decimal point here. Yeah, where should I put my decimal point? Between what two numbers? Yes, so this is 2.87. That's my decimal. Now, times 10 to the what power? So let's see. 6. So let's see here. Is it positive or negative? Positive. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 2.87 times 10 to the 8. Yeah, good. Okay, can you do 2, 3, and 4? And then let me know. So try number 2, 3, and 4. Convert to scientific notation. Oh yeah, thank you. Did anybody else want to turn in the portfolio from yesterday? If you have it, yeah. But this is going to be late though, right? Yeah. late. So can you tell me what the other one? What is it? $6.5 times, what is it? 10 to the 1, 2, 3, 4? Yeah. How about number 3? To the, let me see, so this is my 4.2 and this is my original decimal. So what do I do? 1, 2, 3, 4, 5, 6, or 7? 6 positive? Negative 6. And the last one, 7 times what? Let's see, 1, 2, 3, 4, 10 to the what? Okay, good. Is it doable? So basically, you just, why is the number 3 and 4 negative? And why are number 1 and 2 have positive exponents? Why? Well, yeah, this is a big number. Yeah, bigger than 10. And this is a smaller number, less than 10. So we know the exponent is negative. Yeah? Okay. Doable? Continue, right? Now, we will multiply and then simplify, or divide and then simplify. So the next one is, sometimes you need to simplify. Yeah? So C, multiplying and dividing using scientific notation. Using scientific notation. So sometimes after you multiply, then we need to rewrite into scientific notation again. Because sometimes when you multiply, after we multiply, it's not in scientific notation. So for example, write the answer in scientific notation, or using scientific notation. All right. So number 1, 3.2 times 10 to the 6 multiplied by 2.7 times 10 to the 8. Now, number 2, 5.32 times 10 cubed multiplied by 3.18 times 10 to the 7th. Okay. So let's talk about this. So write the answer using scientific notation. So we want to use scientific notation. So what would you do here? Oh, this is missing the parentheses. Okay. What will we do here? So we will just multiply the numbers with the numbers, right? So 3.2 times 2.7 times 10 to the 6 times 10 to the 8. So we are multiplying the numbers with the numbers. So now you need to use your calculator here. 3.2 times 2.7, which is 8.64. Yeah, good. What about 10? 10 to the what? What do we do here to the exponent? You add them, so 6 plus 8, 14. So 6 plus 8 is 14. So if you multiply two numbers with the same base, we add the exponents. 8.64 times 10 to the 14. Now, the next one, what is the next one here? Oh, is this in scientific notation, by the way? Yes. How do you know this is in scientific notation? You check this number, right? This number is in between what? Between 1 and 10. So yes, this is in scientific notation. Why? Because this number is between 1 and 10. Yeah? Okay. Next. What about this? Same thing. So the numbers multiplied by the numbers times 10 cubed times 10 to the 7th. Okay. So we will just use our calculator. 5.32 times 3.18. That is equal to 16.9176, or you could just say 16.92. It doesn't matter. Yeah. So it doesn't have to be this many decimals. So you could put 16.92. That's fine. Or 16.9176. That's fine also. What about the exponent? 10 to the what? What do we do here with the exponent? We add, so this is 10. Yes. Now let me ask you this. Is this in scientific notation? No, why not? So this number is bigger than 10. So this is not in scientific notation. So not in scientific notation yet. Right? Not in scientific notation. So I don't have space here. Alright. So how do I change it to scientific notation? Well, this is 16. This is, how do I change this to scientific notation again? We move the decimal here, right? So this is 1 point what? 692 times 10 to the what? To the first power, which we usually don't write. Is that right? So 16.92 is, look at this, is 1.692 times 10 to the first power. Should I write the first power? Oh yeah, maybe it's fine. Yeah, because this is not the end product, so I'm just going to leave it. 10 to the first power. Okay, it's not really clear here, but this is 10 to the first power. So 16.92 is 1.692 times 10 to the first power. Now, I still have 10 to the 10 times 10 to the 10. So how do I write these in scientific notation? So 1.692 times 10 to the, what do I do here? Yes, done. Then this is in scientific notation. Doable? Okay. Questions so far before I move on? Well, I mean, we will do more examples. So maybe you should do examples. Okay. So let me give you more examples. Yes, this is done? Okay. Now, number 3. What about if I have 3.72 times 10 to the 5th multiplied by 8.3 times 10 to the negative 7. And then now we will do division as well. 2.8 times 10 to the negative 2 divided by 7.5 times 10 to the negative 7. Now number 5. Actually, I don't need this. What about if I have 8.2 times 10 to the 10th divided by 7 point, no, not 7, divided by 9.9 times 10 to the 12. And then number 6, we have 2.5 times 10 cubed multiplied by 6.2 times 10 to the 7th divided by 1.2 times 10 to the negative 12. Okay. So, what should we do here? All right. So can you guys please try it? Okay. Where's my attendance sheet? Today is Thursday, right? Okay. Is Jennifer here? Yeah. Okay. Henry is absent? Is Jennifer Munoz? Yeah, here. Okay. Georgia? Absent? Caesar? Oh, you're here? Okay. Renee is late. I don't know if she's going to be here or not. Okay. Oh, you're here, Georgia? Yes. Renee Savallo? Not here? Okay. All right, so let me see who's absent today. Manuela is excluded. Sergio is absent. Henry. Where's this? Renee Salcedo and Renee Safama. Yeah. Are you done? So this is basically calculated, right? How do we do this? Well, the numbers with the number. 3.75 times 8.3 times 10 to the 5th powers of 10 with powers of 10. So then use your calculator. 3.72 times 8.3, which is 30.876 times 10 to the, what do you do to the exponent here? Add them. So 5 plus negative 7 minus 2. Okay. Now, is this in scientific notation? No. So this part, this is not between 1 and 10. So I have to change this to scientific notation. So what will this be? So put the decimal here. Yeah. So it is 3.0876 times 10 to the what power? How many units do I move? 1? Okay. All right. So this 30.876 is replaced by this. And this is in scientific notation. Times 10 to the negative 2. Okay. So what's my last answer? And what did we do to the exponent here? We add. So 1 plus negative 2 is negative 1. Finish. Yeah. Okay. Doable or not? Okay. Now, number 4. We're going to divide the number with the number. So, and then the powers of 10 with the powers of 10. Times 10 to the negative 2 divided by 10 to the negative 7. Yeah. So divide, multiply by powers of 10. So what is 2.8 divided by 7.5? So we will just use our calculator. So this is 0.3733. Yeah, or 0.373 times, what do you do to the exponent here? Subtract. Yeah. So what is the result? So minus 2, this is subtract by negative 7. So what is negative 2 minus negative 7? 10 to the negative 2 plus 7. What is negative 2 plus 7? 5th power. Okay. Now, this is in scientific notation or not? Is it? No? Why not? This one has to be between 1 and 10. So this is not in scientific notation. Right? It has to be between 1 and 10. Alright. Now, how do I make it between 1 and 10? Well, move the decimal to between 3 and 7. So this is 3.733 times 10 to the what? 10 to the first power? No, this is negative 1. Yeah? Yes, sir. Yes. You mean 373333? No, you just have to pick 3 or 4 decimal. Yeah, because it's usually, yeah, we usually just use 3 or 4 decimal. Yeah, so we don't have to write down the 0.373 and then this. No need. Yeah, we should just pick 3 or 4 decimals. Yeah? Yeah. Good question. Okay. Now, you need to pay attention that this is not 10 to the first power. Why not? Yeah, we're moving to the right. How do I say it? This is, just think about this. This is less than 1, so the exponent is negative. This is a small number. That's why the exponent is negative. Yeah, this is smaller than 1. Yeah. If 30 is greater than 10, right? Or greater than 1 or greater than 10, I should say this is less than 10. So this is to the negative power. 30 is greater than 10. That's why it is 10 to the first power. That's how you should remember. Yeah, this is point something. This is a small number. The exponent of the 10 is negative. Small number. This is big number. So I will say this is big. So exponent is positive. This is small. The exponent is negative. Yeah. Okay, so this is times 10 to the 5th. So what is this? 3.733 times 10 to the 4th. Okay. Good. Yeah. All right. Did you finish the other one? Number 5? How do I do number 5? This is 8.2 over 9. Multiply by 10 to the 10th over 10 to the 12th. All right. What is 8.2 divided by 9? So 0.911? Okay. 911. 3 decimal or 4 decimal. You want 4 or 3? 3? Okay. Usually we do 4, didn't we? Maybe do 4. It doesn't matter actually. You could do 3 or 4. Yeah. Times 10 to the what? Well, I don't have space there. It's better if I do it here. So this is 0.9111 times 10 to the what? 10 minus 12, isn't it? Okay. So this is 0.9111 times 10 to the negative 2. All right. Is this in scientific notation? No. I have to, how do I replace this? Move it here. So this is 9.111 times what? 10 to the negative 1 times 10 to the negative 2. Okay, so let me use the black for here because I'm not changing this part. Alright, so what is this going to be? 9.111 times 10 to the negative. What do you do to the exponent? What do? You add, right? Negative 1 plus negative 2. What is negative 1 plus negative 2? Negative 3. Yes. So this is in scientific notation. So you add the exponent. Why? Because you multiply. How come you subtract here? Because this is, we divide. If we multiply, we add. Yeah. Okay, last one. Tell me what to do. So deal with the numbers. 2.5 times 6.2 divided by 1.2 times 10 to the 7 divided by 10 to the negative 12. Alright. So let's use our calculator. 2.5 times 6.2 divided by 1.2. So that is 12.9167. if I'm choosing 4 decimals. I could choose 3 or I could choose 2. Yeah. Now, what about this? 10 to the what? 7. 7 what? Minus negative 12. Okay. So 12.9167 times 10 to the, what is 7 minus negative 12? This one, right? Oh, I forgot the 3. You're right. I'm missing the 3. I forgot the 3. You are right. So this is 10 cubed times 10 to the 7th, right? Okay. Yes, you're right. I forgot the 3. I forgot the 10 cubed. No wonder you're looking at me like, where did you get the 7 for? Yeah. That's right. So what happens with the powers of 10? What am I supposed to write here? What do you do to the 3 and 7? You add them, so 3 plus 7. Okay. What do you do to the negative 12? Subtract negative 12. Yes. Good. So what is this? 10 plus 12, which is 22. Ooh, this is a big number, actually. Yes. Is this in scientific notation? No. How do I write it as scientific notation? Yes. So this is 1.29167 times, this is big number or small number? Big. So the exponent is positive 1. Yeah. So times 10 to the 22. Okay. So this is 1.29167 times 10 to the 23. Woohoo! Okay, we're done. Is it hard? It's okay? All right. Okay, good. I'm done with 4.2. So do you remember what this one is? A to the negative m. How do I rewrite using positive exponent? 1 over a to the m. So you remember, right? So for example, if I have 5 to the negative 3, what is 5 to the negative 3? 1 over 5 cubed, and then what is 1 over 5 cubed? Yes, 5 times 5 times 5, which is 125. So practically this is what we learned. Yeah, so negative exponent. Now, when can you leave negative exponent? Only in scientific notation. Yeah, so this is fine. In scientific notation, we could have negative exponent. Other than scientific notation, we have to simplify them so that there's no negative exponent. Yeah, so only in scientific notation, it is fine. Okay? All right, doable? Can I clarify anything before we move on to 4.3? No, we're good? Okay. So let's talk about 4.3 now, polynomial. So later on, just say if you take physics class, anyone later on? Chemistry class. Chemistry probably, yes, you probably use the small scientific notation. For physics or astronomy, you probably use bigger number. Yeah? All right, so let me stop. So we're done with 4.2, negative exponent and scientific notation. We will start 4.3, which is polynomial. This is short. Yeah, polynomial. So let's start again. Maybe close this. All right. Now let's share the desktop. Okay. 4.3, polynomial. What are polynomials? This one we know actually. Okay, let's see. Polynomials. Terms. Yes. What does terms mean? Types of polynomials, degree and coefficient. So A. Terms. So a term is a number or a constant, yes, or a product of a number and some variables. And some variables. Oh, actually, I should say a term is a number or a variable, or so it's three possibilities. Alright. So, give you an example. So, examples of a term. So, 5 is a term. Negative 7z is a term. Y is a term. xy squared z is a term. Negative 2xz is also a term. Yeah, so each one of them contains one term. Okay. So we can combine like terms. What are like terms? Like terms are two or more terms with the exact same variable parts. Yeah. So like terms are two or more terms with the exact same variable parts. So for example, 5x squared and negative 7x squared are like terms. Six y and 8y are like terms. How about 7y cubed and negative 2y squared? Are they like terms? Are not like terms. Yes? Okay, so we know we can combine like terms, right? Yeah. So, for example, let's see. Add or subtract. So add or subtract. Number 1. 3x cubed minus 7x squared plus 2x minus 5x to the 4 plus 3x cubed minus 8. So this is simple. 2/3 x to the 4 minus 1/4 x cubed plus half x minus 1/3 x to the 4 plus half x cubed plus 1/3. Okay. X to the 4. Which one? This one? Example number 1. Number 2? This one? X to the 4th. Yeah. So this is X to the 4th. Okay. Yeah, I know it looks like Y. This one looks like Y also, actually. Let me fix it. This is 5X to the 4th. Alright. So for number 1, which ones are... Oh, okay, let me wait for you first. So which one should we do first? Do you want to do it? Number 1 and 2? Do you know what to do? Yes, sir. Huh? What did you say? Can we do one? Oh, you want to do one? Okay, so tell me, on number 1, which ones are like term? 3x cubed and 3x cubed, yes. So that is negative 5x to the 4th, right? Plus 6x cubed. How do we get 6x cubed? Combine 3x cubed plus 3x cubed. Okay, and then minus 7x squared plus 2x minus 3. Yes, good. Yeah, so nothing else, right? That's it. Good. Yes, correct. Now, number 2. What are you going to do with number 2? So maybe you could write them next to each other. Which one is x to the 4th? Let's see. So why don't you try it first? Yeah, try it first. 2 minutes. Let me give you one more with fractions. Let's see. Or do you want decimal? So number 3. Or maybe I will give more space. So number 3, let's see, 1 over 6 x cubed plus 3x squared minus 1/3 x cubed plus 7 plus x squared minus 10. All right. Try it, please. These 2. So what would you do? Let's just say number 2. What would you do? You could keep them close to each other. So 2/3 x to the 4th minus 1/3 x to the 4th. Okay, then what? Minus 1/4 x cubed plus half x cubed. Then what? Plus half x plus 1/3. Yeah? Okay. So now you can factor this out, the coefficient out. So this is just 2/3 minus 1/3. And then what about the second one here? Negative 1/4 plus half. And the last one, oh, nothing to do, right? So you don't have to add. Okay, can you work on these? And number 3, really quick. Okay, good. Let me know when you're done, okay? Finished? Okay. So, what's the answer here? So what is 2/3 minus 1/3? Yes, 1/3 x to the 4. Now, what about these? Plus, I'm going to use my scratch. Negative 1/4 plus half. So this is scratch, and this is done in scratch paper. So how do I add these? Come on, you know this. How do I add those? Which is 4. Yes, so this is negative 1. What about these? Times 2. So this is 2/4. So what is negative 1/4 plus 2/4? Yes. So this is 1/4 x cubed. And what about these? Plus half x plus 1/3. Okay. So if we have fraction, probably it's easier if we write it as factors like this. Did you see it? Yes. I don't add the exponent? No, you only add when you multiply, right? These are like terms. So we keep the exponent. Like if I have 2 apple plus 2 apple, what would this be? 4 apples, not 4 apple square, right? So you can only add if you have like terms. Yeah. So remember, 2 apple plus 2 apple is equal to 4 apple, not equals to 4 apple square. Okay, good. Now let's see, x cubed. What do I have for x cubed? Maybe write it like this faster. 1/6 minus 1/3. Yes. X squared. What do I have for x squared? Oh, this one's not fraction. I could do it easily. 3x squared plus x squared. What is 3x squared plus x squared? Yes, 4x squared. Do I have x? No. And then I have 7 minus 10. What is 7 minus 10? Negative 3. Okay. So now on my scratch paper, I have to calculate 1/6 minus 1/3. Okay. So 1/6 minus 1/3. How do I calculate this? Common denominator, which is 6. Okay. So this is 1/6 minus 2/6. So this is 1 minus 2/6. What is 1 minus 2/6? Negative 1/6. So this is just negative 1/6 x cubed plus 4x squared minus 3. Is it easy? Okay. Doable? So when do you write it as factors? When do you factor out the expression? When you have fractions only, right? Otherwise, we will just add 3x squared plus x squared, that is 4x squared. Yeah? Can we do anything else? This is x cubed, x squared, and negative 3. Can we do anything else? No, you can't. Why? Because they are not like terms. Yes? Okay. Good. Questions? No, we're good? Okay. Now let's talk about polynomial. Okay. So B, polynomial. Yeah, we're almost done. So polynomial. So, what does poly mean? Many. Right? Okay. So even though it says many, so poly, this root means many. More than one. Yeah. But it also includes monomial. So what does monomial mean? What does it mean? One term. Polynomial with one term. So give me an example of a polynomial with one term. 3x or 5 or negative 1. Binomial. What is it? 2 terms. It's a polynomial with 2 terms. Give me an example of binomial. Come on, you know. 5x squared minus 8. That's a binomial. Yeah. Trinomial. 3 terms. Give me an example of a trinomial. negative 6x cubed plus 7x minus 2. That's just an example. So 3 terms. Yeah. So all of these, even though the first one is only 1, it's called polynomial. Yeah. Okay. So now let's talk about the degree. Yeah. So or let's talk about the terms of polynomial. Terms of polynomial. Okay. So suppose I have this polynomial. 5x to the 5th minus 3x cubed plus 2x minus 7. How many terms does it have? Yes. This is a polynomial with 4 terms. Yeah. So what are the terms? So the terms are, tell me, 5x to the 5th. What else? Negative 3x cubed. What else? 2x and negative 7. So those are the terms. Right? Those are the terms. Now, can you tell me what is the coefficient and the degree of each term? So coefficient and the degree of each term. So I am looking at each term now. So let's see here. I have these 4 terms. I have 5x to the 5th, negative 3x cubed, 2x, negative 7. What is the coefficient? 5. What is the degree? Just 5. Yes. Yeah. So the degree is this exponent right here. This is the degree of the term. Yeah. Can you fill out the other one? What is the coefficient for the second one? Negative 3. What is the degree? 3. Yes. The degree is the product, the number of times the variable is multiplied. So if it is x to the 5th, then it is multiplied 5 times, right? So that's the degree is 5. Next, coefficient to the degree. Okay, next. Coefficient, negative 7, degree 0. So constant has degree 0. A number or a constant has degree 0. So a number which we call a constant has degree 0. Yeah. Okay. So this last one, negative 7 here. This is a constant. The degree is 0. So what I was doing here was all the coefficient and degree for each term. Yeah. Now the next one is, let's talk about the leading. I'm almost done. 2 more minutes. Leading coefficient and leading term. All right. What is the degree of the polynomial? Okay. So suppose I have 7x to the 5th minus 3x to the 4th plus 3x cubed minus 2x minus 5. So I'm looking at the whole polynomial. What is the degree of the polynomial? Which one was it? Yes, the degree is 5. Yeah. Do you know which one I'm looking at? So I'm looking at this, the highest one. Okay, that's the highest one. Which one is the leading term? No, leading term. Leading term is the first one, which is what? 7x to the 5th. Yes, so this is the leading term, the first term in the polynomial, the term with the largest, highest exponent, highest variable exponent. What is the leading coefficient? What is the leading coefficient? 7, yes. Good. Yeah, so in this case, we look at the polynomial as a whole. Now, here we look at each term, yeah? But in this case, we look at the polynomial as a whole. So far, so good? Is it easy? Are they doable? Yeah, okay. This is 4.3. Basically, I'm done with 4.3. The other one is evaluating, meaning substituting. Yeah, so it's not that hard. I'm done with 4.3. So Monday, no class. Tuesday, Dr. Casimir will start 4.4. Yeah? Okay. All right, guys, what homework do you on Sunday? Up to 4.3. Yes? Okay, you have a good one. I will see you in 1 week. Well, more than 1 week. Yeah, 1 week plus 3 days. Okay. Have a good one. All right. Yes.
Okay, so I do math Excel on my phone, but am I wrong here? Because I think the base is 3, but it's saying it's not. I tried it twice already.
The base is x.
It is.
Yes. The 7 applies to x, not to the 3.
So where's the 3 considered?
3, so just say, okay, your question is, just say if I have, hold on. Just say if I have 5a cubed, okay? So this is 5a times a times a. Why? Because the cube only applies to a. So if I have this, negative 2 to the 4th, this is, this exponent applies to which one? To the 2 only, not to the negative. So this is negative 2 times 2 times 2 times 2. If I have negative 2 to the 4th, this is a different story though. 4th applies to. So in this case, the base is, yes.
Thank you.
Yeah. So you're gonna take the test right now? Let me see if I have it, okay? If not, I have to go to my car or to my office. All right. No, probably I don't have it. So no. Let me go to my car or to my office. Can you wait? Yeah. Are you ready to take the test?
Yeah.
Okay. Let me save this first. All right. So math 115. Oh, file name is 4.3. Polynomial. Okay, so we are done with 4.3, and next time it will be 4.4.
So each 4.4?
Dr. Casimir.
Okay.
Yeah.
Only 4.4 and 4.5.
I don't know what's going to happen on Tuesday, depending on how much he's going to be here Tuesday, Wednesday, Thursday. Let me stop the recording again.